Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to conclude our series on LeChatelier's principle, talking about temperature changes. If you want to talk about concentration or pressure changes, please watch one of the previous videos, because this video is only about temperature changes. So let's do a quick review on LeChatelier's principle. It says if a system's at equilibrium, okay, and there's this disturbance, then according to LeChatelier's principle, it's going to counteract that disturbance. So if you do this, I'm going to do that kind of idea with LeChatelier's principle. Okay, and since we're talking about temperature changes, we're going to say, well, what if we increase or decrease the temperature for this particular system? What is LeChatelier going to do to counteract that disturbance? Okay, well, the pivotal piece of information that we need to know about this equation is it exothermic or is it endothermic? That piece of information is critical. So I go in, I look at my appendix, okay, and I look up the enthalpy change for this by doing products minus reactants, okay, and I realize that this has a negative 92 enthalpy change, okay. Now the negative is saying, hey, this energy is being released, okay. So as this chemical reaction takes place, we're going to release some heat energy. So since it's exothermic, since this is a negative sign and it's exothermic, we are going to put the word heat on the product side, okay? If this was endothermic, we would end up putting heat on the opposite side, and that's why that piece of information is so critical. But this one is exothermic, it's releasing heat, so we're putting heat on the product side. And after that, this problem gets actually very, very simple. So if my action is to come in and increase the temperature, that's my action. So if I do this, then LeChatelier's principle is going to do that, which is the opposite. How do I go about countering that? Okay, the counteraction has to be a decrease in temperature. Well, how do you decrease the temperature? By decreasing the heat. And if that decreases, so does this, and these guys go up. And my question to you is, what type of shift is this? Well, if the products are going down and the reactants are going up, we would say that that is going to be a shift to the left. So when this shifts to the left, okay, and we take a look at our Kc value, okay, remember that's going to be the products over the reactants, where the exponents, okay, are the coefficients in the equation. So 3 on the hydrogen and 2 on the NH3, okay. So if this shifts to the left, these guys are going to go up. So this value is going to go up, this value is going to go up, and this value is going to go down, okay? What does that do to my over Kc value? Okay, it's going to end up making it lower, okay? Now, one thing about the other two changes is that when we change the concentration or pressure, okay, the K value stays constant. Just the reaction shifts to the left or to the right, okay, to reestablish its K value. So the K value never changes, okay? However, with temperature changes, if we change the temperature, the equilibrium constant is going to be adjusted, okay? And if you have an exothermic reaction where you increase the temperature, the counteraction is to decrease that temperature and shifting all these values to the left, okay? So there's more reactants than products. And if you have more reactants than products, the K value is going to go down, okay? And that's how all of this works, okay? So for temperature changes, the K value will change. It'll either get higher or lower, okay? Shifts to the left will lower your K value. Shifts to the right would increase your K value. So for this exothermic reaction, when we increase the temperature and it shifts to the left, we will get a lower K value. Of course, the opposite would be true. If I lowered the temperature, well, we would have the counteraction would be to create more heat. And if we create more heat, we're creating more products. And this would shift to the right, leading to a higher K value. So temperature changes will always lead to a change in the equilibrium constant's value, okay, when we have these shifts to the left or to the right. But with the first two in our video series, when you made those changes, the equation shifted to the left or to the right just so that it could get back to its K value. I hope you found this information helpful. If you do, please give it a like and subscribe. When you leave that comment, it really does push the information out to other students that might be interested in learning chemistry.